Hey there, science fans! Welcome to another exciting journey into the wonders of our natural world. Bill Nye here, and today we're diving into the amazing world of the nitrogen cycle. You might be wondering, why should we care about nitrogen? Well, let me tell you. It's more fascinating and crucial than you might think. Now, you might be thinking, nitrogen? That sounds boring. But hold on, because this element is a key player in the game of life. But trust me, this stuff is way cooler than you think. Nitrogen is involved in so many processes that keep our planet and all its inhabitants thriving. Nitrogen is like the building block of life. It's essential for the growth of plants, which in turn provide food and oxygen for animals and humans. Without nitrogen, our ecosystems would collapse. It's in our DNA, our proteins, even our coffee. Yes, that morning cup of joe you enjoy wouldn't be possible without nitrogen. But here's the catch. Even though nitrogen makes up a whopping 78% of the air we breathe, we can't just suck it in and use it like we do oxygen. Our bodies need it in a different form. It's like having a fridge full of delicious food, but it's all locked up in containers you can't open. Frustrating, right? Imagine having all the resources you need right in front of you, but being unable to access them. That's where the nitrogen cycle comes in. It's nature's way of unlocking that nitrogen treasure chest and making it available to all living things. This cycle involves various processes like nitrogen fixation, nitrification, and denitrification, which transform nitrogen into forms that plants and animals can use. So buckle up, because we're about to explore the wild ride of nitrogen as it transforms and travels through the environment. From the soil to the atmosphere and back again, nitrogen is on a constant journey that supports life on Earth. Get ready for some serious science fun. We're going to break down the nitrogen cycle step by step, and by the end of this adventure, you'll see just how vital and exciting nitrogen really is. So let's get started. Picture this. You're surrounded by a giant invisible ocean of nitrogen gas. That's what our atmosphere is like. It's full of nitrogen molecules, each one made up of 2 nitrogen atoms stuck together like best buddies. But here's the thing. Those nitrogen atoms are bonded together so tightly that plants and animals can't break them apart. It's like trying to build a house using bricks that are glued together with superglue. Impossible! So, how do we get those stubborn nitrogen atoms to loosen up and join the party of life? That's where things get really interesting. Enter the superheroes of the nitrogen cycle, nitrogen-fixing bacteria. These tiny organisms play a crucial role in maintaining the health of our ecosystems and the productivity of our agricultural lands. These microscopic marvels have the amazing ability to convert atmospheric nitrogen into a usable form through a process called, you guessed it, nitrogen fixation. This process is essential because although nitrogen is abundant in the atmosphere, plants cannot use it in its gaseous form. These bacteria are like tiny chefs with a secret recipe. They take the inert nitrogen gas from the air and transform it into ammonia, a form of nitrogen that plants can absorb and utilize for growth. They hang out in the soil or in the roots of certain plants like legumes, think beans and peas, forming symbiotic relationships. In return for providing the plants with nitrogen, the bacteria receive carbohydrates and a safe environment to live in. These bacteria use special enzymes to break those tough nitrogen bonds. It's a complex and energy-intensive process, but these tiny organisms are up to the task. It's like they have tiny hammers that can finally crack open those superglued bricks. Once the nitrogen bonds are broken, the bacteria convert the nitrogen into ammonia, which plants can readily use. The result? Ammonia, a form of nitrogen that plants can actually use. This ammonia is then further processed by other soil bacteria into nitrates, which are even more accessible to plants. Thanks to these nitrogen-fixing bacteria, our crops can grow strong and healthy, ensuring food security and sustainable agriculture. Now, ammonia is a good start, but plants prefer their nitrogen in a slightly different form, nitrates. That's where nitrification comes in. This 2-step process is like a relay race, with different types of bacteria passing the nitrogen baton. First, ammonia is converted to nitrites by bacteria like Nitrosomonas. Then another group of bacteria, like Nitrobacter, steps in to convert nitrites to nitrates. Think of it this way. Ammonia is like raw cookie dough, while nitrates are the delicious baked cookies that plants love to gobble up. Section 5. Assimilation. Plants enjoying a nitrogen feast. With nitrates finally on the menu, plants can finally enjoy their nitrogen feast. They absorb these nitrates through their roots and use them to build essential molecules like proteins and DNA. It's like plants are building amazing structures with nitrogen Legos. These structures help them grow tall, produce flowers, and create seeds for the next generation. And guess what? When animals eat plants or other animals that have eaten plants, they also get that precious nitrogen, which they need to build their own bodies. Section 6. Decomposition. Nature's recycling program. But what happens when plants and animals die? Do their nitrogen treasures go to waste? Not a chance. That's where decomposition comes in. Nature's very own recycling program. When organisms die, decomposers like bacteria and fungi get to work breaking down their complex organic matter. Think of these decomposers as nature's cleanup crew, transforming dead stuff into simpler compounds. It's like taking apart a giant Lego structure and sorting the bricks back into their containers, ready to be used again. Section 7. Ammonification. From dead stuff to ammonia. During decomposition, nitrogen-containing compounds in the dead organisms are converted back into ammonia. This process, called ammonification, is like returning those nitrogen Legos back to their basic form. Remember that ammonia can be used by plants for growth, so this step is crucial for returning nitrogen to the soil and keeping the cycle going. It's like a continuous loop of nitrogen goodness, ensuring that this essential element is always available for life to thrive. Section 8. Denitrification. Back to the atmosphere. But wait, there's one last step in our nitrogen adventure. Remember those nitrogen-fixing bacteria that started this whole cycle? Well, some bacteria are also involved in returning nitrogen back to the atmosphere through a process called denitrification. These denitrifying bacteria are like the ultimate nitrogen recyclers. They convert nitrates in the soil back into nitrogen gas, which is released back into the atmosphere. It's like those nitrogen Legos are finally returning to the big Lego bin in the sky. Section 9. The Circle of Life. Nitrogen's never-ending journey. And there you have it, folks. The nitrogen cycle is a continuous loop of transformation and exchange, a process that is both fascinating and essential for life as we know it. This cycle begins in the atmosphere, where nitrogen gas makes up about 78% of the air we breathe. However, this nitrogen is not directly usable by most living organisms. To become usable, nitrogen must first be fixed by certain bacteria found in the soil or in the roots of some plants. These bacteria convert nitrogen gas into ammonia, a form that plants can absorb and use to grow. This is the first step in a series of transformations that make nitrogen available to all living things. It's like a never-ending game of nitrogen hot potato, with bacteria, plants, animals, and the environment all playing their part. Plants take up the fixed nitrogen and use it to build proteins and other important molecules. When animals eat these plants, they take in the nitrogen and use it to build their own bodies. When plants and animals die, decomposers like fungi and bacteria break down their bodies, returning nitrogen to the soil in the form of ammonia. Other bacteria then convert this ammonia back into nitrogen gas, which is released into the atmosphere, completing the cycle. So, next time you take a deep breath of air, remember that you're inhaling the same nitrogen atoms that have been cycling through our planet for billions of years. Pretty cool, huh? This ancient cycle is a testament to the interconnectedness of all life on Earth. The nitrogen cycle is not just a scientific concept, it's a vital process that sustains ecosystems and supports the growth of plants and animals. Without it, life as we know it would not be possible. It's a reminder of the delicate balance that exists in nature and the importance of preserving our environment. That's the power of the nitrogen cycle. It connects us all in a grand, invisible web of life. Every breath we take, every bite of food we eat, and every plant we see growing is a part of this incredible journey. So let's appreciate and protect this amazing cycle that keeps our planet thriving.